All right, so welcome back to OneClass. Again, my name is Joey. I'm going to be your chemistry teacher for this session. So for the next hour, what we're going to do here is we are going to answer hopefully about 10 organic chemistry level questions. So these are basically questions you would typically see in a university and college level context, and I'll be trying to go over these questions for you, and I'll verify the solutions as we go on. Again, if you're tuning in for the first time here at OneClass, what our goal is that we are providing and curating these resources. So we're creating live streams and creating these videos for teachers such as myself to answer these questions, so we can teach you the concepts behind these questions so that you're better prepared for tests and assessments as we go moving forward despite the COVID-19 situation. So that's kind of our goal here. That's our goal here at OneClass. Again, my name is Joey. I'm going to be your chemistry teacher for the session. I come from a background of having a bachelor's in science in terms of chemistry, and I'm also a high school teacher, so I'm a secondary school educator as well. So without further ado, let's get started on these problems that we have for today. All right, so our first question here is kind of a fill in the blank question. So this one here, these we have a bunch of key terms here. So we have alkyl boranes, oxidative, Suzuki, aryl boranes, metathesis, reductive, ligands, Heck, Simmons-Smith, Grubbs, and carbines. So we basically have these keywords. We're kind of just matching these keywords. And this one, they actually already gave us the answer in this case. So we're not verifying the solution here. But I just want to go over and read to you like some of these reactions here. So metathesis is reactions between two alkene molecules that result in the interchange of the carbons of their double bonds. So again, they're interchanging their double bonds between two alkene molecules. This is a metathesis kind of reaction here. Carbines here are neutral reactive intermediates that contain a divalent carbon surrounded by 6 electrons. The lone pair and two each form the R groups here. So that's carbene. That's what definition of a carbene is. A Heck reaction is palladium catalyzed coupling of a vinyl or aryl halide. It's good here. Ligands here are groups coordinated to a metal, which donates electron density. So you can think of ligands as in terms of a Grignard reagent, where you have magnesium has a metal here, and it's kind of bonded to the alkyl halide group, creating a negative charge that's kind of stabilized by the magnesium positive charge here. So that's kind of a ligand, for example of a ligand. Reduction, as we know, is elimination of two groups that surround a metal. It creates C bond H or C bond C bonds, carbon-carbon bonds here. That's good. Alkyl boranes have a boron atom attached to a benzene ring. So repaired by organolithium reagents by reaction with trimethyl borate. So again, if you have a boron atom attached to a benzene ring, it becomes an alkyl borane. Simmons-Smith is a reaction with alkenes and diiodomethane in the presence of copper activated zinc to form a cyclopropane. So you have alkene and you're forming a cyclopropane, and it's stereoselective as well for Simmons-Smith. An oxidative reaction is you're again adding a reagent to a metal, increases number of groups around the metal by 2. Finally, Suzuki is kind of like Heck, where it's palladium catalyzed as well, but then you're forming a new C double bond C bond using an organic halide with the organoborane. Whereas for the Heck one, it's a vinyl aryl halide with an alkene to form a new C bond C bond. So Suzuki and Heck are very similar in terms of palladium catalyzed, but one uses organic halide with an organoborane, whereas one uses a vinyl or aryl halide with an alkene. So again, I'm going to say the solution here is correct. Again, it's just a bunch of text here. It's just a kind of a fill in the blank kind of question here. I'd just say great solution in this case.